Good morning, all of you. In today's session, we are going to discuss about human eye and colorful world. It is the part of 10th class chemistry. So we already started a series of lectures which are going to be covered on our 10th class chemistry. Being a part of this, we already finished unit 2 and also even. So unit 3 portion got completed acid, bases and salts. In today's session, we are going to continue with the human eye and colorful world. So in the previous session, we got started this unit. So in that we got with introduction and what is the minimum distance up to which, so from which distance we are able to see and maximum distance up to which we are able to cover, and what is the entire structure of this human eye. So everything got covered in the last session. In today's session, we are going to discuss about what are the defects which are observed in the vision. So when any problems arise in the human eye, what kind of defects, vision impairment is possible, especially myopia, hypermetropia and presbyopia. So these three topics are going to be covered in today's session. So let us enter into our actual concept. Right. So now we are going to discuss about eye lens and change in the focal length. Okay. So how eye lens? So we are already know various parts which are present in the human eye. Human eye consists of pupil. Around the pupil we have iris, and in that, so eye lens will be there which is directly attached to the pupil, and the eye lens will concentrate the light whichever coming from the outside source, and that concentrated light will fall on the retina, which is back of eyeball, and this information will be transported into optical nerve. So millions of optical nerves are present in the eye. So that information now transformed to brain. So brain will analyze and predict the information whatever received from this optical nerve. This is the entire process of vision. In this, eye lens, how eye lens will be able to adjust, so adjust the focal length. So some of the objects are very near to us, some other objects are far distant from us, and some other in the in between this place. So in this way we are not able to see the objects whichever present in our surroundings. They are not in the fixed distance from one object to any other object, so that distance will be varied. So when such kind of variation in the distance is possible, how can we observe all these objects in with a clear vision? So for that purpose, there is an adjustment in the focal length is possible, which is done by this part called eye lens. How it will do and what is the process we are going to discuss now. Okay, so in the first condition, if the object is placed far away from the eye, so here we can clearly see this light is far away from the eye. Then how this light is captured? So this object is captured by the what eye lens, and which falls on the retina. So retina is able to give the image of real picture, but that is in the inverted manner. So this is about the process of image given by this object on the retina, right? So now let us see how focal length will be adjusted by this eye lens. So this eye lens is surrounded by ciliary muscles. These ciliary muscles are very essential, which are the strong part which are used to cover the entire eye, and it is a protective layer used to secrete some mucus and also lacrimal glands, also tears also secreted by these ciliary glands, and these muscles are used to adjust, used to what elongate and compress themselves in order to adjust the focal length of this eye lens. So especially these ciliary glands, ciliary muscles plays a vital role in order to adjust the eye lens focal distance. Okay, so by changing the radius of curvature of the focal length, adjustment is possible. Okay, so when we are adjusting the radius of curvature, this radius of curvature is present on the surface of ciliary glands. By changing its radius, it is possible to adjust this focal length. Okay, so in that way here adjustment is possible, so that all the objects, whether they are very near to us, otherwise far away from the human eye, can be captured without any difficulty. Okay, so if we see the object for distance, ciliary glands get relaxed. In that case, ciliary glands will not get strained and there is no need to do any kind of extra work, and these ciliary glands are exist in the form of relaxed state if the object is present at far distance. So in the second condition, you can clearly see object is far away from the human eye. In that case, the glands which are present in the protective layer got relaxed, right? So in this case, focal length of the eye lens will be maximum. So the focal length, in order to concentrate this light coming from the object, that should be concentrated whenever, so whenever focal length is maximum. So that's why in this case focal length will be maximum, and the distance is equals to distance from the retina. Whatever focal length we are getting from this outside material is exactly similar to that of focal length of this eye length from retina. Okay, in that case clear vision is possible. So this focal length is nothing but distance between the object to the eye lens should be equal to that eye lens to the retina. If that distance are coincided with each other, in that case clear vision is possible to us. Okay, so now let us see eye retina and its components, how retina is able to capture the vision and capture the image, and how the information is passed into the optical nerve. Let us discuss about this retina and its components. Retina is the part which is the most important region where the image got captured with the help of this eye lens. There is a fixed length between this eye lens and this what we can say retina, and this retina is composed of 125 millions of rods and cones. On this retina we have different type of materials which are called rods and cones. The purpose of rods are used to identify the intensity of the light. Strength of the light will be analyzed by these rods, and cones are very essential to identify the size and color of the object. What color object is present in front of eye and what is the size of object can be analyzed by using these cones. Cones used to visualize the colors, and rods are used to identify the intensity of the light. These are the important components which are present in this retina, and around 125 million rods and cones are arranged in this manner. Here we can clearly observe how the cones and rods are present in this retina. Now it is connected to millions of optical nerves which are directly linked to this retina, right? So the retina now transport the information to this optical nerve, and further they get analyzed by the brain. So interpretation, what kind of information obtained from this retina is possible by the brain. Okay, so this is about retina and its components and the work of that rods and cones which are present in the retina. Now we are going to discuss about maximum and minimum distance of the focal length. Okay, then how can we measure this focal length? What is the empirical formula in order to measure this focal length? So in order to calculate this focal length, we are going with two different conditions. Two different conditions are going to applied. One is image, if image is present at infinite distance, so it is far away from the human eye, infinite distance place we are keeping the object, that object we are going to see now. Object is at infinite distance and the focal length of eye is very maximum. Okay, so in infinite distance case focal length will be maximum. Here we can clearly see the image. So in this image what you can see, here is the eye lens is there, the object is far away from the human eye, so these light rays get concentrated. So this lens used to concentrate all these light radiation coming from the object, and this information now falls on the point where retina is present. Here single digit point is generated on this retina. Okay, so light rays from the infinite distance object falls on the eye lens, then make a real inverted image on retina. Now, retina is used to capture the real-time image of inverted shape. In order to calculate the focal length, we have different components on it. U and V are present. So U is nothing but infinite distance where the object was placed. V is the minimum fixed distance which is present in between retina and eye lens. So the fixed distance between the retina and the eye lens is given denoted as V, and the object distance from the human eye is denoted as V. So this U value will be minus infinity. V value is that is fixed 2.5. In order to calculate the focal length, the formula will be 1 by F is equal to 1 by V minus 1 by U. F stands for focal length, V is the distance between the eye lens and retina, U is the distance between the object and the eye, right? So 1 by F is equal to, what is V value? 2.5 plus 1 by U. U value is infinity. So that is, here we have minus sign for infinity, and here also minus sign is there. Minus into minus, it will become plus. That's why the value becomes 1 by F is equal to 1 by 2.5 plus 1 by infinity, right? Always 1 by infinity value is taken as 0. That's why 1 by F is equal to 1 by 2.5. That is nothing but focal length maximum is equal to 2.5. Why it is indicated as maximum? Whenever object kept in the infinite distance, the focal length is known as focal length maximum. That's why focal length maximum is given as 2.5. So this is a condition where object is kept far away from the viewer. Okay. Now let us apply condition 2. Image at definite distance of 25 centimeters. We are keeping the image exactly at 25 centimeters distance from the human eye. In this case, let us apply the focal length formula. U is equal to, the object is at minus 25 centimeters and V is, that is fixed distance, 2.5. Then 1 by F is equal to 1 by V minus 1 by U. So 1 by F is equal to 1 by V value is 2.5. There is no change. But U value will be object kept at 25 centimeters. That's why minus into minus it will become plus. That is 1 by 25. 1 by 2.5 plus 1 by 25. Let us take LCM of these two. Now 11 by 25 it will be. Okay, 11 by 25. Now let us take F, focal length of minimum. This is known as focal length of minimum, is given as 25 by 11. It is calculated as 2.27. So F, focal length of minimum, is taken as 2.27. Now we have the important prediction here. If the image of object in between minimum distance, the focal length adjusted in between 2.5 and 2.7. If object is present in between minimum distance, so that is the definite distance is there. Now focal length is adjusted in between 2.5 to 2.27 to get the clear vision. 2.5 is the distance between the retina and this lens, and 2.27 is the minimum distance up to which you can clearly see without any difficulty. Okay, so this is about the case 2. Now let us go with eye defects and its correction. Okay, so as of now we discussed about what are the components present in the eye and how can we calculate the focal length and what kind of parameters are present which are related with the vision of the eye. Now we are going to discuss what kind of problems arise in the eye vision and how can we correct them. Okay, so basically when eye is the part of optical visionary organ which used to capture all the objects whichever present in our surroundings. So those objects which falls in the visible region can be clearly visualized by the human eye. So that kind of property is present. But due to some kind of changes or deformations in the system of eye, there is a possibility of vision impairment. Vision defects are possible. What kind of defects are possible in general and what kind of its corrective methods are there. Those will be discussed now. Okay. So as already we know, focal length is the distance between the objective here, eye lens. That distance is taken as the focal length, and that focal length is naturally adjusted by that human eye with the help of ciliary muscles, which are used to protect the entire human eye. So in that case, this focal length adjustment is possible and the vision is very clear even the object is far away or near to the human eye, right? So this focal length is not adjusted in accordance to the distance of the object. In that case, there is a possibility of eye defects. If we are not able to adjust our vision focal length, so focal length is not by default adjusted, in that case eye defects are possible, and the exact image of the object will not fall on the retina, so information is not captured by retina, so that it is not sent to the brain through the optical nerve. So the main reason is focal length adjustment is not possible in general, right? So vision impairment and blurredness induced due to lack of accommodation. What is meant by accommodation? Accommodation stands for adjusting natural adjustment of the focal length by human eye with the help of that eye lens is called accommodation. Because of this accommodation only we can see the objects even they are present near or far away from the viewer. Okay. So lack of accommodation, if that adjustment is not possible in general, in that case blurredness, otherwise we can't see the object entirely, or that kind of alphabets may not be visualized. That type of vision defects are possible to human eye. So here three different kind of general human defects, vision impairments are observed, so which are mainly due to this focal length adjustment is not possible. One is myopia, second is hypermetropia, third is presbyopia. So they are the diseases which are mainly observed in the human eye defects. Let us discuss one by one. First is about myopia. Myopia stands for near objects are clearly visible. The objects which are far away, that may be object, that may be any kind of print, any alphabets, all those cannot be visualized if those are far distant to the human eye. So only near distance objects are clearly visible. That is called myopia. Alternate names for myopia are nearsightedness, also known as short-sightedness. Means near objects are clearly visible, far objects are very difficult and they get blurred to the human eye. That kind of condition is said to be a myopia. This is an eye disorder. Light focus in the front of retina instead of on the retina. So under normal vision conditions, it is very clear that object image falls on the retina so that we will get what object is present in front of us. So in case of myopia person, that object falls in front of the retina, but not exactly on the retina. Okay, only it falls in front of the retina, so that information is not captured by the retina, so we can't see the object exactly. So this is called myopia. So because of this reason, blurredness is induced whenever object is far away from the human eye, and whenever myopia is there, headache is possible and eyes get strained because we have to see more particularly in order to visualize the object. That's why eye stress is possible. And if severe nearsightedness is present, that leads to retinal detachment. So retina will not respond to the vision, and cataract is the another disease, and glaucoma is another eye disorder which is generated. If this kind of situation defect is continued for several days, there is a possibility of the diseases like cataract, glaucoma, and retinal detachment. These are the some other defects which are associated with this myopia, right? Myopia stands for only the near objects are visible, far away objects are very difficult to visualize. Okay, so in this case, that image of object will not fall on the retina. Retina will not get any information about the object, so that vision is blurred. Right. So when we use such kind of opticals, it is possible to see the objects very clearly. With a normal vision, normal human eye, it looks like a blurred one. It's clearly represented in this picture. By using opticals, it is possible to see very clear manner, right? Eye lens forms an image in the front of retina rather than on the retina. This is the main cause of this myopia. So lens is not in the fixed position. Lens orientation is also not in the um, uh, fixed orientation. So in that case, what happens? Image will not fall on the retina, and that picture will not be captured by the retina. Healthy person is able to see objects which are present far away, and even infinite distance objects are visible to the human eye. But myopia persons are not able to see the distance less than 25 centimeters only, the focal length of this human eye. So they are able to see the pictures up to certain distance. Beyond the distance, the entire pictures will be blurred. Hence, you can say it is the short sightedness, or otherwise it is also known as nearsightedness. Okay, so here 4 pictures are provided to you. Among the 4 pictures, let us take first condition. If the object is far distant from the human eye, so you can say far distant from the human eye. Here picture is covered, picture is captured in the front of retina but not on this retina. In front of retina you can capture the picture. In the second case, if image is placed somewhat near but not on exact point where visibility is there, so infinite distance to some closer distance we drag the object, but still it is not possible to visualize that image on the retina. In third condition, the object is kept at the point called M. The object is kept at the point called M. Now, the image of this object will fall on the retina, and the object is clearly visible to the human eye. In this third condition, let us take fourth condition, where image is present, object is present below this M point. M stands for the maximum point till which myopia patient is able to visualize the object very clearly is called point M. Point M is the maximum distance up to which the person able to see clearly in case of this myopia. Okay, so from this myopia point, the object is clearly visible. After this myopia point, if object is there, that will not give the entire image of that on retina. So yeah, from this myopia point, you will get the image on this retina, right? So when we are taking object shorter than this myopia point, in that case also image is invertedly placed, invertedly concentrated on the retina, and those are clearly visible. This indicates what? After the myopia point, if any object is there, those are not visible. Below this myopia point, whatever object is there, those are clearly visible to the human eye. So this kind of defect is known as myopia, short-sightedness, nearsightedness. M is the point of vision defect which is present in the myopia. Right? So M is the far point till which myopia person is able to see the objects very clearly. So that is the maximum point. After this M point, that object is not visible to the human eye, to them. L is called the least point of the object visible clearly. So up to which distance there is a minimum distance is called L point, maximum distance is called M point. Okay. Now let us see how can we correct this vision defect of myopia, and what kind of lenses are suitable in order to correct this kind of defect. Okay. So for this purpose, for myopia defect correction, we have to use the lens of concave. Concave lens is suitable in order to correct this kind of myopia defect. So normal vision person, here 3 different conditions are provided in the picture. Normal vision person, healthy human eye was taken, and in the fixed distance we kept one particular object. Human eye can capture that and will concentrate on the retina and exact image is clearly visible. Picture is very clear to the human eye. This is the healthy human eye. And the second condition, same distance object was placed, but the person is suffering from myopia now. So if he is suffering from myopia, this object picture is not falling on retina. Instead, it will fall in front of retina. The object picture is placed in the front of retina. So this condition is said to be a myopia. And in order to correct this myopia, we are inserting a concave lens. Concave lens was inserted, that is the additional support, because in general human eye should do this thing, but here because of its deformation, what we are doing, we are taking external aid, that is the concave lens. Concave lens kept in between the object and human eye. This will concentrate the image and this will extend the picture and it falls on the exact position of retina. So this concave lens used to extend the image picture and it exactly falls on the surface of retina, so that the vision is very clear. Now, by using this external concave lens, it is possible to correct this myopia. Now, let us calculate focal length for this one. In order to correct this myopia, the suitable lens will be biconcave. Biconcave lens can be used. It will adjust the focal length by using these lenses. These are mentioned in this figure, right? So now image falls on the retina. So what is meant by biconcave lens in the sense? Biconcave in the sense, two inverted curves will be there. Both the sides curvature will be appeared. So in both the surfaces curvature is there. That is said to be a biconcave lens. These lenses have negative focal length. Always their focal length value will be a negative. Hence, this myopia is also known as negative sight. Myopia is also known as negative sight because focal length value will be negative. Let us see how it will be calculated. U is taken as minus infinity. V is taken as D, minus D. U is taken as minus infinity. V is taken as minus D. This is applicable to myopia persons only. Now let us apply the focal length formula. 1 by f is equal to 1 by minus d plus 1 by alpha. Focal length formula, 1 by f is equal to 1 by minus d plus 1 by alpha, right? So now it becomes 1 by infinity always, sorry, this is not alpha, infinity. 1 by infinity always 0, that's why 1 by minus d. So 1 by f is equal to minus d, nothing but f is equal to minus d. So we are taking this, these two are in 1 by state. Now we are reverting the equation, f is equal to minus d. So always focal length value is given in terms of negative for this myopia patients. Okay, so this is about myopia. Now we are going to discuss about the another defect called hypermetropia. Okay, so just consolidate all myopia. Myopia stands for if any person who is suffering from the vision defect of longer distance, clear vision of objects which are very near to them are possible, called myopia. In order to correct myopia, we have to use concave lens. So biconcave lens is required. Biconcave stands for both the sides curvature is there and the surface is known as biconcave. So those are used to correct the vision defect of myopia. Always myopia defect focal length is denoted with negative. Hence myopia is also known as nearsightedness, short-sightedness and also negative sightedness. Hypermetropia. Now we are going to discuss about next defect called hypermetropia. In case of hypermetropia, we have alternate name called long-sightedness. Long-sightedness in the sense they are able to see the objects which are far away from the viewer. Far away from the viewer, those objects are clearly visible. The objects very near to the eye, or it is very difficult to observe them. Especially in the case of reading, if you are reading any book, you feel very difficulty while reading because objects are very closer to the human eye. In that case, they are not able to see the picture of that object very clearly. That is called hypermetropia. So in case of hypermetropia, So when the object is placed very near to the eye, this lens is not able to focus that light on the retina. Instead, the image will be formed beyond this retina. So after this retina, this image formation is possible. That's the reason why this retina will not get any information about that object, and you can't see that object in a clear manner. So this is reverse to that myopia. In myopia, in front of the retina, image will be formed. In case of hypermetropia, image will be formed backside of this retina. So still it will go backside of retina and image will be formed, and image information is not gathered by the retina. So you can't get any vision of that object placed very near to the eye. This is known as far-sightedness, otherwise long-sightedness. Okay, so long-sightedness, hypermetropia is also known as hyperopia, right? So the blurredness effect is mainly due to incoming light being focused behind the retina instead of on the retina, right? So due to insufficient accommodation by the lens. Accommodation is nothing but adjust in the focal length in order to concentrate the light on exact position of retina is called accommodation. But lack of accommodation is possible. Instead of retina, the picture formed behind this retina, that condition is said to be a hypermetropia. Here, three different conditions are provided to you. H point is there, that is hypermetropia point. So at this hypermetropia point, what happens? So that let us move this. So object picture is falls away from this retina. So backside of retina, you can concentrate this image picture in case of metropia, right? So if the picture is present, away from this hypermetropia point, that directly falls on the material and you can clearly visible that one. If picture is present away from this hypermetropia point, again in this case also you can clearly see the image of that. That means far away objects are very clearly visible. The objects which near to the human eye are very difficult to see them, right? H point in hypermetropia stands for the minimum distance up to which vision is clear. After this distance, that means, before this H point, the vision is blurred. That point is said to be a H point, which is hypermetropia point. Hypermetropia defect, the minimum focal length is greater than 2.27. So below this 2.27, they are not able to see anything. After this 2.27 distance from the human eye, they are able to see all the pictures which are present away from the viewer. Hence, image formed behind the retina. So away from the retina, image will be formed. So the picture will become a blurred one, right? These people can see the vision clearly from the distance. Distant objects are very clear, but closer objects are very blurred in nature. In order to correct this kind of defects, we have to use the suitable lens that is called convex lens. Here, we need convex in order to correct image from behind to on the retina, right? Here it is very clearly mentioned. How can you see? So in hypermetropia patients, what happens? Image falls behind the retina in first condition. In second condition, we inserted convex lens here, which is suitable lens. Convex lens is inserted in front of the human eye so that object will be concentrated exactly on the retina instead of behind the retina. So in this way, here convex lens is used to capture the light exactly falls on the retina. Now let us calculate its focal length. Focal length for this hypermetropia is given as V is equal to minus D, U is equal to minus 25. Okay, so V is equal to minus D, U is equal to minus 25. Now 1 by minus D, minus into minus it will become plus, that's why 1 by 25. 1 by F is equal to D minus 25. Sorry, F is equal to, this is right. 1 by F is equal to, so when we take LCM, it will become D minus 25 by 25D. So after calculating what happens, 1 by F is given by D minus 25 by 25D. always this value is greater than 25. This is a condition of hypermetropia. D value is greater than 25. In that case value becomes a positive, because we are subtracting some term from higher one, higher to lower term. For example, here we have 30 minus 25, it will become what? Positive integer only. So in that case, f value becomes a positive, because d is always greater than 25. So 25 is the vision distance. So minimum vision distance from human eye. So always this d value is greater than that one, because far objects are clearly visible to this hypermetropia patients. So this is about the calculation of focal length. Focal length is given as negative for myopia. Focal length is given as positive for this hypermetropia patients. So that's why it is called positive sight. Hypermetropia is known as positive sight. And the last kind of defect is known as presbyopia. Okay. Third type of defect is known as presbyopia. Let us see how it will be appeared and what kind of defect it will be. Normal vision, what happens? The real image of the picture will be fall on this retina and that will be captured. In case of presbyopia, there is a possibility of vision image away from the human eye, otherwise in front of the retina. That means there is a possibility of myopia or hypermetropia. Both are possible, but this kind of condition is arised due to aging of the person. As age growing, what happens? Ciliary gland movement becomes difficult, and if their movement is very difficult, human eye vision effectiveness will be reduced. Worsening of ability to focus clearly the objects is known as a presbyopia. This is purely based on the aging of the people, and because of ciliary gland movement becomes difficult and focal length adjustment is not possible in general. In that case, presbyopia is possible. It may be the combination of myopia and hypermetropia. Otherwise, myopia is possible, or hypermetropia is possible as well. Okay, so this is purely because of loss of flexibility of ciliary glands. Now, let us go on to how it can be corrected. How can we correct this kind of defect? In order to correct this defect, here we have to use the lens of bifocal lens. Okay, bifocal lens are required in order to correct this presbyopia. So here, how can we correct bifocal length in the sense? So upper region is made up of concave lens and the lower portion is made up of convex lens. This upper portion is used to visualize the objects which are present far away from the viewer, and the lower portion is used to visualize the objects which are present very near to the viewer. Okay, so in order to read the newspaper, this convex lens will be useful. If you want to see any board which is present, in case of that one, concave lens will be utilized. In this way, right, a bifocal lens is nothing but it is the combination of concave and convex lens. Upper portion is consist of concave lens which used to visualize the objects of far away distance. If you want to see the board of any hoarding or any board, in that case concave is utilized. If you want to read the newspaper, convex lens can be utilized. So in this way, here this optical prism will be made by combination of concave and convex lens as well, which is known as bifocal lens. This is used for the correction of presbyopia. Presbyopia stands for, so because of lack of adjustment, lack of accommodation of focal length due to lack of flexibility of ciliary glands due to aging process, here vision becomes difficult and blurriness induced. In order to correct this, we can take the combination of concave and convex lens so that far and near objects are clearly visible to the human eye, right? So now let us see another topic, very short topic of this human eye, that is power of the lens, right? Whenever the person suffering from any, that may be myopia or hypermetropia, so we have to use a suitable lens. In order to choose the suitable lens, we have to check its power. right? So all the individuals may not have exact kind of vision defect. Based on their vision defect, power of the lens will depend. So by adjusting that focal distance artificially, it is possible to correct the human vision defects, and objects can be clearly visible. Now let us see what is meant by this power and how it can be calculated. So power of the lens is a reciprocal of focal length. Focal length is nothing but distance between the object to the human lens, eye lens. That is taken as the focal length. When we are reversing, when we are inverting this one, that entity is known as the power of the lens. So power of the lens is a convergent or divergent light. So that is always a reciprocal of the focal length, and it is denoted by P is equal to 1 by F in meters. Otherwise, 100 by F, it can be measured in centimeters. Power of the lens is denoted with the term called D. D denotes diopter. Okay. So by using this one only, we can choose the selective lens which is suitable for what kind of defect, right? So this power is denoted with the term called D. D stands for diopter. Now let us see how it can be calculated. Already we know this power is the reciprocal of focal length. That means P is equal to 1 by F in meters, 100 by F in centimeters, right? So if doctor suggested 2D, 2 diopter lens, then what will be the focal length? In order to calculate that, we have the formula P is equal to 100 by F. P is given as 2D. That means 2 diopters. So 2 is equal to 100 by F. F is needed to be calculated. F is equal to 100 by 2. Now 50 is the focal length of the that kind of vision impairment. Okay. So in this way, there is a relation between this power of the lens and the focal length. Power of the lens is nothing but reciprocal of the focal length. So it is calculated by taking the formula P is equal to 1 by F. Okay. So always it is denoted with the term called D. D stands for diopter. By this, we completed vision defects and what are the suitable measures to correct that kind of vision impairment. Okay. So myopia, hypermetropia, and one more term is presbyopia. These 3 topics got covered in today's session. Hope this session is very much helpful for you. Thank you very much for your patience listening. Thank you one and all.